All right, so to find the cosine of theta over 2, we're going to be using the same triangle that we did in the last part when we found the sine of theta over 2. And again, we know that theta over 2 is going to be in between pi over 2 and 3 pi over 4 because we just divided the values in this interval by 2, which puts us in quadrant 2. This is in quadrant 2. And we know that the cosine in quadrant 2 is negative, which means we're going to be using the negative version of this angle, or of this formula, sorry. So the cosine of theta divided by 2 is going to equal negative square root of 1 plus the cosine of theta all over 2. So go ahead and plug in the values that we have here. So this is going to be minus the square root of 1 minus, 1 plus. The cosine is negative 2 over rad 5. So negative 2 over the square root of 5, all divided by 2. This is going to be subtraction, and then we can rationalize by multiplying by rad 5. So it's going to be 1 minus 2 rad 5 over 5, all divided by 2. And again, this is negative because the cosine is negative in this quadrant. And then multiply everything by 5 to get rid of the fractions. And we get 5 minus 2 rad 5 all over 10. And that's going to be the negative radical of that. Then we can multiply 10 on top and bottom to help us with rationalizing this. So multiply by 10 times 10 times 10. And we're going to get the square root of 50 minus 20 rad 5. And this would all be over 100. But then if you broke it up into two radicals, we just have the negative square root of 50 minus 20 rad 5 all over 10.